Good evening, and welcome to Chapter 3. In Chapter 3, we're going to be taking a look at objects that move again. We're going to be describing that motion, but now we're going to take the giant step instead of just moving forward and back, so in a straight line. Now we're actually going to take a look at how things can turn. But in order to do that, we need to take a look more closely at this concept called vectors. Now, we've introduced the concept of scalar and vector previously in previous classes. Vectors, remember, have special properties because they not only give us the size of something, but also the direction. And because of that, they have to be treated in a special way. So we're going to start off with today's lesson and just review vectors. So, quick reminder, scalar is a quantity that is magnitude only. Now, another word for magnitude, and I'm going to put this up because I'm going to highlight it. Because sometimes people freak out like, well, I can't find magnitude on my reference table. I don't know what it is. Magnitude is just a fancy word for size. It's the size of the quantity. So like if I tell you that I have 5 fingers up, it's 5 fingers. There's no direction there. If I told you that I walked 5 miles today, you don't really know what direction I ended up or where I went or anything like that, but you do know how far I went. Vectors, on the other hand, provide us with not only the size, but also the direction. So it's going to be more information. If I told you, hey, I walked 5 miles north, then you could say, oh, well, if he started here, here's where he ended up. And so it allows you to have more information about that. So I just want to let you know that in some of our sample problems, you're going to see that vectors have bold-face type. Because remember, we've already talked about, we've said that D is both distance, but it can also be displacement. I'm not writing it all out. So how do you know which one's which? Well, if it's a bold D, then it is a displacement. Or V is for speed, but it's also velocity. Well, how do you know? Sometimes it's bold. The other way that we'll sometimes notate vectors is to put a little arrow over the top. So if you see like a V with a little arrow hat on it, a little hat on it, that's called the vector hat. That designates the fact that it's a velocity and not just a speed. Now, because the vector tells us both size and direction, we have a special way of notating them. You don't always want to say, hey, 5 miles north, 10 meters per second east, 27 meters per second squared down. You don't always want to have to write that out, all those words. So we will represent them as an arrow. And so when you have a vector, you will have an arrow where the size of the arrow, the length of that line, represents the magnitude, or the size of the vector, what it represents. And then the arrowhead tells you the direction. So in this case, this arrow could represent, and I'll put it in orange, this could represent 3 steps. And you would know that I went 3 steps to the east. Now, because it only gives us a length, we will have to use a, you're going to have to use a scale. My brain fried there for a second. So if I would represent this, I would actually measure this out and say, oh, okay, well, I've got this length. So this length right here would represent 1 step. And so I can say, hey, 1 step is equal to that distance. And so if I wanted to draw, say, a vector that represented 4 steps to the west, what I would do is I would have 1, 2, 3, 4. And I'll put in the black mark so you can see. There's 1, 2, 3, 4. And then put my arrowhead on. But once again, this amount represents 1 step. And so as long as you have that scale, you can know how big and what it's going to represent. So I can write down here, hey, this is 4 steps west. That's what that vector represents. Okay, this gets especially important for when we're doing like velocity. So if let's say I'm traveling at 5 meters per second north, obviously I can't draw an arrow that's 5 meters per second. And I'm going to slide this over just a touch. What I would have is I would have a scale. I would say, hey, this distance right here is going to equal 1 meter per second. And so if I were to represent that, the 5 meters per second north, I would have to go, okay, here's 1, 2, 3, 4, 5. Now again, this is approximate. I'm going to actually use a ruler and a protractor when we come into school. And when we practice this in here. But again, that's my 1 meter per second. That's my 1, 2, 3, 4, approximate. This represents 5 meters per second to the north. Okay? So we have to have that scale in order to know what those vectors, what those arrows represent. Now, the important rule of thumb for adding vectors is you always have to be added head to tail. This is crucial. I'm going to highlight this. Head to tail is the key piece. And let me give you an example. Now, here's the example. Let's say that my problem is that I walk, I'm going to write this out. I walk 3 steps east and then walk 4 steps east. Now that's nice and easy. And you're like, okay, well, if I were to represent this as a vector, and I'm going to say, hey, as a vector, I'm going to say, hey, this distance right here, that represents 1 step. Okay, and we're going to do this with rulers so it's more accurate. So then my first vector is going to be 1, 2, 3. There's we'll call this vector A. And then vector B, which I'll put in purple, is going to be 1, 2, 3, 4. And so if I were to add these together, what I would do is I would take B. Okay, now this is going to look crazy, but see if you can follow this along. I'm going to take B, and I'm going to pick it up, and I'm going to move it and attach it to the head of A. And so if I now look at this, now I have a full vector. Oops, hang on. Let me go back to purple. There we go. I have a full vector. If I go start from the start, the beginning, here's where I started. This right here represents A plus B. And I know what you're thinking. You're like, dude, this is like crazy easy. Why do I have to do this? I know that if I walk 3 steps east and then 4 steps east, that's going to equal 7, and life is good. I mean, I don't really need to do this. But here's the other trick, and we talked about this already. I'm going to do the exact same thing, except now I'm going to rewrite it, and I'm going to take my walk 3 steps east. And then I'm going to walk 4 steps west. And so I'm going to draw the exact same thing. I'm going to do the same thing. I've got A, which is my 3 steps. I'm going to have my B, which is 4 steps. And notice I've drawn them to scale. A's pointed east, B's pointed west. But again, now the deal is that I have to add them head to tail. So again, watch this. I'm going to take B. Oops, hang on. Hit the wrong thing. I'm going to take B, and I'm going to attach the tail of B to the head of A. And so what I'm left with, my resultant, the result of adding A and B goes from the tail of the first to the head of the last. This is A plus B, which in this case is equal to 1. And so 3 plus 4 is 1. And I know right now your mind's going to go, just mind's blown. But I can represent that. If I start right here and I walk 1, 2, 3 steps to the east, and I turn around and I walk 1, 2, 3, 4 steps to the west, I am 1 step to the west from where I started. So even though I did 3 plus 4, my result is going to be 1. I ended up 1 step away from where I started. Okay? So the rule of thumb is that whenever you're drawing these, you have to add them head to tail. And I'll highlight that right here. Added head to tail. Added head to tail. Okay? So we're going to practice this a lot tomorrow. But the result, those green lines are called the resultant. It is the result of adding 2 or more vectors. Result of adding 2 or more vectors. And we'll practice with this a little bit tomorrow. Now, I'm going to talk about this really, really quick, but then we'll go back and do it. If 2 vectors are parallel, the resultant is the sum of their magnitudes, and it's in the same direction as both. So let me go back up and take a peek. If you looked, we walked 3 steps east, 4 steps east. They are parallel vectors. They're both pointing the same direction. They're parallel. The result was just adding them together. Okay? And so I'll come back down. So now I'll write this out. 3 steps east plus 4 steps east equals 7 steps east. We just added it. Again, the diagram's up there. We'll practice this tomorrow. However, if 2 vectors are epiparallel. Now, this is a term that I made up. This is probably not going to be found in any dictionary. But when I say epiparallel, that means these vectors are still parallel lines. It's just they are now in opposite directions. So that's like the second example I did, where I went 3 steps east plus 4 steps west. In that case, my result was 1 step to the west. And what I did was I just subtracted them. So if they're parallel, I add. If they're epiparallel, I subtract. And that allows us to find out the magnitude, the size of the resultant. The direction is going to be in the parallel, same direction as the other 2. In epiparallel, the direction of the larger one. Okay, and again, we can go back up there and just show that as well. That was this example. Walk 3 steps east, 4 steps west. I forgot to put my B there. Hang on. There we go. And so adding them epiparallel, they're epiparallel, add them head to tail, gave me a result of 1 step to the west. And we will practice this a lot. Okay? Now, there's one other situation that we're going to do, because right now we've dealt with parallel and epiparallel. If 2 vectors are perpendicular to each other, so I do my 3 steps east. And then I go 4 steps north. Okay, and so I'm going to draw this. I'm going to go back up, and the first one was orange. So 3 steps east. We'll call this vector A. And then we've got 4 steps north, and I'll make this here. 4 steps. We'll call that B. And so what I'm going to do here, and actually I'm going to move them around. I'm going to attach A, the head of A to the tail of B. Oops, too far. There we go, right like that. And so I attach them together. Now my resultant, the result of adding those 2 goes from the tail of the first to the head of the last. This is the result. Resultant, that's A plus B is right here. And since this is a right angle, we can use Pythagorean theorem. Now, of quick reminder, Pythagorean theorem, a squared plus b squared equals c squared. So in this case, it would be 3 squared plus 4 squared, and that's going to give me a resultant of 5 in this case. 5 steps in that direction. Okay? We'll talk about how we're going to find that direction later on. So we'll practice this as well. If we want to subtract vectors, subtracting vectors is actually really, really easy. And it's because of this property right here. It's a property of vectors. The negative of the vector has the same magnitude, but points in the opposite direction. And so, if I go A plus B again, and we'll do the same ones before, we'll do, hey, here we'll go 3 steps east, and we'll do 4 steps west. Okay, but if I want to subtract these, here's what I'm going to do. My first one, here's my 3 steps east. Call that vector A. We'll do 4 steps west. That's vector B. And so if I want to do A minus B, now again, I'm going to do something tricky mathematically. A minus B is the exact same thing as A plus a negative B. A negative B, and I'm going to put this in a light blue just to distinguish it from B. This is negative B. And so this is still 4 steps. But now it's in the opposite direction. And so if I go back and I run my rule of adding them head to tail, I'm going to pick up negative B, slide up here, attach it to the head of A. And so my resultant, I'll put it right up top here. This is A minus B, which in this case gave me 7 steps to the east. And so 3 minus 4 gave me 7. I know it gets a little crazy. We're talking some nutty stuff, okay? But that's what we have to do. Again, it is always add them head to tail. That is the rule. Anytime you're adding them vectorially. So anytime you're adding them. The last thing we're going to talk about today is called multiplying vectors by scalars, okay? This is, again, really simple, really easy. So let's say that I have my vector A. Let's say we have 3 steps east. And I'm still going to draw that. So there's my 3 steps to the east. And we're going to call that vector A. If I want to multiply it by a number, by a scalar, then all I have to do is just increase the magnitude by that amount. So if I want to go 2 times A, and I'll put this in green, 2A, all it would be is in the same direction, but now it's going to be 2 times 3 steps, so 6 steps. I probably should have put that in green. You get the idea. Actually, I can do that. Let's circle this and change this bad boy to green. There you go. All right, and so we're going to play around with this. We're going to do some problems with this tomorrow. We're going to draw these out. We're going to get out rulers. We're going to get out protractors, and we're going to practice drawing these and adding these together. It is a good thing to visualize what's happening with this because we're going to take these vectors and then apply them to algebra. But you still have to be able to draw them. So we'll practice this again tomorrow. Everybody have a great night. See you later. Bye.